plants that belong to the land of sets. Now, for most of you, I suspect 6th grade was a long time ago. Which I don't know about you, but I think that's when I learned about sets. When did you guys have sets? When did you ever learn about sets? Have you ever learned about sets? You have not learned about sets? Which is
learned about it? I forgot.
Okay.
I know it was at least 6, but it's quite
I've heard the word. I recognize the word. All right. So let me tell you about my most amazing collection of baseball cards. Look, here's a baseball card. Oh, hey, here's another baseball card. Yay. And here's another baseball card. And this is my favorite player, player A, and player B, and player C. And I guess I got some more.
E-player forever.
Yay. I got another player C because he was on a different team or a different year. I don't know what baseball cards are done. So these are baseball cards. You guys know what baseball cards are, right?
Yes.
Maybe you can put them on your bike and you. Okay, great. All right. So if I want to come up with a set, now careful. I'm going to do it slowly, but if you don't watch carefully, you could actually hurt yourself. I'm going to turn it into a set. You ready? Here it comes. And you always have to do this counterclockwise. Poof! That's a set. This is a set. What does my set contain?
ABC.
What? ABC what? Baseball cards. Let's make it real. Okay, let's just keep it real here, okay? How many baseball cards are there in my set? Cool. And what's the order? Which one's first?
No. There's no order.
What? So would it be fair to say a set is like a bag full of beer cans that you put in the back of a pickup truck and then you go down a bouncy road? Could you say which beer can's on top? Could you say which beer can's on bottom? Left, right? No, you can't. Do you know where anything is in that bag of beer cans after you get to the end of the bouncy road? No. But can you say there's beer cans in the back? You can. All right. Cool. All right. So this is a set. Guess what? This is also a set. How many sets do I have?
There's 2 sets.
Already, you guys are starting to master the world of sets. Cool. There are 3 operations, only 3 operations that you can do on sets. The very first one is called union, and it's denoted by a, not really, it's actually sort of a fancy union symbol, but it sort of looks like a U. All right, I'm going to unionize these 2 sets, set 1 and set 2. I want to apply the union function to it. Once again, highly sophisticated, sort of complex technical stuff, but let's give it a shot. Doesn't this just remind you of Mrs. Johnson's 5th grade? Whoever your 5th grade. A union of these 2 sets. Oh my God! How many baseball cards are in the union of those 2 sets?
6.
Are they all in one set? Cool. And can we tell which one's first now?
No.
No. But all we can tell is how many baseball cards are in the set. How many baseball cards are in the set? 6. And they're in how many sets?
1.
Because that's the result of union between the 2 sets, right? Okay. This doesn't really seem like it's really hard to do, but alright, so we go back to having 1, and then we got our other. Next, remember I told you there's 3 functions, right? Called intersection. Intersection has to do with what is the common point between those 2 sets. What do both sets have? So in terms of baseball cards, what's the intersection between those 2 sets? Player C. Is it fair to say that both of my 2 existing sets have a baseball card of player C? Is that correct? All right. So if I have to figure out what the intersection was, it turns out, now, when we did union, the result was what? It was a set. Turns out that when we do intersection, guess what? The result is also a set, and what does it contain? C. And arguably, really all it would contain is like 1. Because sets can only contain 1 of anything. That make sense? So if you have a duplicate, go ahead and add it. It doesn't matter. there will only be one of whatever in that set. So the intersection of our two sets results in a set with how many things in it? And what does it have in it? What card? Card C, right? Come on. Now the last one that we have, last set function, there's only three of them, right? First set function was what? Union. Second one was intersection. Third one is difference. What do you think we're going to get when we do the difference of these two sets? Basically everything but C. You know, nobody ever said set tend to be round. So that incredibly ugly looking set is the difference between the two. It says what things are not in both sets. That make sense? That turns out to be what cards A, B, D, and F, right? Poof. We have just completed our trip back to 5th grade. You now know everything there is to know about sets. And baseball cards. Now, how about if we talk about sets in Python? So what is a set? A set's a container that stores a collection of unique values. You've got another container, don't you? What's the other container that you have in Python? Lists. Can you store stuff in lists? Okay, can you store stuff in sets? Apparently that's what that says, right? However, unlike a list, the elements or members of a set are not stored in any particular order. Remember the bag of beer cans in the back of the pickup truck going down the bouncy road? So they're in there, yay, but they're not in any order. So when you add something 1, you add something 2, you add something 3, 1, 2, 3 doesn't matter. They're just in the set. It doesn't matter what order you added. Okay? Operations available for use with the set are the same as the operations performed in mathematics. Guess what? What we did here was everything having to do with sets in mathematics. Union, intersection, and difference. Okay? Because sets need not maintain a particular order, set operations are much faster. Python likes sets a lot because it doesn't have to do all the housekeeping to keep things in proper order. An example of sets for your pleasure early in the morning. Can we talk about pizzas? All right. What goes into a cheese pizza? 3 things. Creamy garlic Parmesan sauce, cheese, and a little bit of toasted Parmesan on top. Pepperoni pizza, marinara sauce, cheese, and pepperoni. And of course, the over-the-top meat lovers pizza gets marinara sauce, pepperoni, Italian sausage, slow-roasted ham, hardwood smoked bacon, and seasoned pork and beef. Just makes you hungry thinking about it, doesn't it? All right. Now, does this sort of smell like a set? Maybe? 3 ingredients? And this is like another set. And then this is like just a crazy out of control set, right? So if I wanted to make a cheese pizza set, how would I go about doing this? Well, first off, I use these little squiggly brackets. Woo, squiggly brackets. How cool is that? And I say cheese pizza, which is going to be the name of my set, equals creamy garlic, Parmesan. I think I got screwed up on quotes there. Creamy garlic, Parmesan sauce, cheese, and toasted Parmesan. Bam! You got a set full of ingredients for a cheese pizza. Now, I can do something else here. I could actually turn it into a list, and then I could turn the list into a set. So here we go. You've seen this before. Cheese pie equals square bracket, creamy garlic, Parmesan sauce, cheese, and toasted Parmesan, square bracket. That's your old buddy, your old pal, Mr. List, right? We've seen it 100 times. Now remember, this is item 0, this is item 1, and this is item number 2, correct? Fantastic. Now I'm going to screw everything up. Cheese pizza equals set, paren, ooh, cheese pie, paren, pow. Now I've got a set called cheese pizza. Guess what's in the set? 3 things, right? And which one of those is first in my set? Trick question, trick question. Man, would that be such a cool final question? Here's I put a bunch of stuff into a set. list the item that is first in the set. Trick question, right? Yeah, I love that. I have to think about that one. Okay, for historical reasons, you can't use squiggly bracket to make an empty set. I'm not so sure what those historical reasons are, but whatever. Anyway, so if you want to start a set and if you want it to be empty, the way you do it is you say, variable name that's going to be set equals set paren. Bam, you've got yourself an empty set. Okay? As with any container, remember, lists are containers also, you can use length with it. So number of ingredients equals length, L-E-N, paren, cheese pizza. In our particular case, what would length come back with? How many ingredients are in a cheese pizza? Right. So we can't tell the sequence. We can't tell 1, 2, 3, but we certainly can tell the number of things. So in our example of beer cans in the bag at the back of the pickup truck, can you open up the bag and count the beer cans?
Yeah.
Yeah. Can you tell where any particular beer can is? Nope. But you can tell how many beer cans are in the bag, right? Cool. Okay, is something in a set? Is your question. Fantastic. We can check to see if something's in a set. And we use the in or we use the not in operators. So if toasted Parmesan is in cheese pizza, the set cheese pizza, then say, oh, cheese pizza contains toasted Parmesan. Otherwise, a cheese pizza does not contain toasted Parmesan. Bam. So in is the magic in there. Okay? Sets in order. Sets are unordered. Remember, we're not even sure what's first or second. So you can't access the elements of the set by position, like you can do with the list. How? But you can use a for loop to go over it and pull out each and everything in there. So print the ingredients in the cheese pizza are, for ingredient in cheese pizza, print it out. Now what's going to happen is everything's going to come out of the set. Okay? I will pull out each individual item, but I have no clue as to what sequence it's going to come out of. The order in which they come out is going to be depending on how they're stored internally. So the ingredients in the cheese pizza are toasted Parmesan, creamy garlic, and cheese. All the way back here, remember we had creamy garlic, cheese, and toasted Parmesan. So the way we had find it was different than the way it's being printed out. The order of the elements can be different from the order in which the set was created. You got no clue on order. Okay? So in the set, you got no predictions, no thought, anything as far as order. Order has no meaning. Now the fact that they don't retain their initial ordering is not a problem. And the reason it isn't, because we can make it actually very efficient. And we can do a bunch of funky things. For example, 4 ingredients in, here it comes, sorted. Cheese pizza. Print the ingredient. How's it going to sort it? Numerically. First come first. Tastiness. Alphabetically, right? So it's going to sort it alphabetically. I usually want to display elements in a sorted order, use the sorting function which returns a list. Oh, yeah, that's it. So basically, this functionality, sorted cheese pizza, is cranking out a list, and then the ingredient is going to go stuck into the list. So not that it matters that much, just ingredient is basically considered to be a member of the list. Adding elements to a set, hey, I've got a great set, I'd like to put more stuff in it, not a problem whatsoever. Like lists, sets are collections, so you can add and remove things. Meat lovers pizza, dot, add, quote, unquote, mushrooms. Cool. All right, that's pretty much how we add stuff to other things. But here's the key thing that's actually really, really important. A set cannot contain duplicate elements. So, if I have a set of colors, blue, red, and green, and then I come along and I add blue to that set, and then I ask it, hey, you got blue, it's going to tell me what? How many blues are going to be in that set?
One.
Just one. Right? You can add the same thing over and over again. The set's going to say, fabulous, give it to me. By the way, I already got it. It doesn't really matter. I'm basically going to throw it away if you're adding something I already have. But I'm not going to complain. I'm not going to give you any grief. I'm just going to accept it and go on from there. Which makes an interesting point. So let's think about this. Let's say Amazon came to you and said, hey, we'd like you to write a program that would allow the people who've been buying for us to check a database to see if we've ever sold a product before. So Amazon sells how many products now? A lot. Let's say 100,000 products. They sell 100. But over the last 10 or 20 years, or however long they've been around, do you think they've sold a lot of products that they no longer sell?
Yes.
Probably. So what would you want to do? And in fact, they may have sold the products, not sold it, and then sold it again, right? I mean, that's entirely possible, right? So if you were going to create a database for Amazon that contained all the products they've ever sold, could you use a set to do that?
Yes.
And could you use a list to do that?
Yes.
Which one should you use?
I would use the set.
Why?
There's a lot of, not only Amazon itself, there's other companies who may sell similar products or the same product, and then you'll have it in that list multiple times if you use the list.
Yeah, but I could come up with some code to search my list. So if I had ladies flowered hats, right? And I sold it 10 years ago, and now I'm going to get ready to sell it again, or one of my vendors is going to sell it. I could add that to a list, right? And I could do a search on the list for ladies flowered hat that's already there and not add it to the list, right? Or I could have a set. What would I do on a set?
You just add it.
I just add it. Ladies flower hat, add it to the set. And what's the set going to do when I do that?
If it's already in the list, it just doesn't matter.
It's just going to throw it away, right? It just throw it away. I won't even know it, right? Is it going to complain if I add something that's already there? Got no problems. It'll thank me very much and ask me if I got more, right? All right. All right, removing elements from a set. Okay, now a couple different ways to go about doing this one. The first one is dot discard Italian sausage from our meat lovers pizza set. If you do that, discard, and it's not in the set, meat lovers doesn't have an Italian sausage. Sad. It will not complain. They'll just go, well, there's nothing to do. And it will continue on with your code. Not a problem. Ain't got no Italian sausage, but it's no harm, no foul. Everything's cool. Everything's good. Okay? However, if you use dot remove, which sure seems to be similar to discard, Italian sausage. If Italian sausage is not in the set, it's going to throw an error. Whoop. In fact, the program will come to a crashing halt. Unless use the technology that we talked about in our last meeting, which was, remember, try. Remember our little try block? You do something, if there's an error, you can have an exception where you jump to that, and then you do something. Oh my God, go find the Italian sausage, because apparently it's not in the set. And then there's the finally, the code that always gets executed each time. So if you want to trap an error, hey, if Italian sausage is not there, take some other action. You use remove. If you don't care, hey, get rid of Italian sausage, and if it's there, get rid of it, and if it's not there, whatever, I don't really care. Then you use discard. Okay? And if you have a set that for some odd and strange reason you now want to clear out, get everything out of that, I'm starting over. I want to clear everything out of that set. You use the dot clear command, and it just wipes everything out of the set. The set's still there, it hasn't gone away, it's just that it contains nothing. Subsets. Alright. What we got here? So a set is a subset of another set if and only if every element in the first set is also contained in the other set. The other set can have more stuff. Okay? But everything in that first set is already in there. So let's take a look at this. We use is subset as a method. So here's cheese pizza. And cheese pizza, I'm saying I got marinara sauce and cheese. Okay? And a pepperoni pizza, I'm saying I got marinara sauce, cheese, and pepperoni. That's why I call it pepperoni. So would it be fair to say that cheese pizza is a subset of pepperoni pizza? Okay? Everything here is here. Is everything here here? No, it's that pepperoni. Okay. So the question is, cheese pizza is a subset, friend, pepperoni pizza. Is that going to come back true or false? True, right? Okay, that's cool. Comparing subsets, or sets, you use your old friends equal or pound sign equal. Cheese pizza is not equal to pepperoni pizza. I think you can all agree with that, right? However, cheese pizza 1 is equal to cheese pizza 2. So we'll worry about having Python take a look at everything in your set and say, hey, you got everything, all the same stuff in both sets, or do you have different things in different sets? Set, union, intersection, and difference. Exactly what we did right here. All right. Cheese pizza union with pepperoni and pizza. Remember, that's all we got there. Okay, marinara sauce, cheese, and pepperoni. Remember, union, we're putting them together, right? So everything in cheese, everything in pepperoni, union means we put them all together, right? And so we end up with everything that's in both of those. Marinara, cheese, and pepperoni. Intersection of the two sets contains all the elements that are in both sets. Cheese pizza and pepperoni. So what's in both cheese pizza and pepperoni? Two things, right? Marinara sauce and cheese, exactly. So what's missing from that list? Pepperoni, right? The difference of two sets results in a set that contains those elements that are in the first set that are not in the second set. Cheese pizza over here, pepperoni pizza over here. You know what the ingredients are. What's in one of those sets that's not in the other set? Cheese pizza, pepperoni, what's the difference between the two? Pepperoni. That's all there is to it, right? Poof. And that's what we see down here. Cheese pizza, difference, pepperoni pizza, bam, we get pepperoni. That's all there is to it, not that complicated.
How cool is that?
Hey, look, what's in your Python toolbox? A brand new shiny set tool. Dang, man, that is so cool. All right, what did we cover today? Well, we talked about sets. We talked about sets in order. In fact, that there is no order in sets. We talked about adding to a set, which is always a good thing to do. As long as you're adding, you should be able to remove from a set, so we know that's important. We talked about subsets that are less than everything that's in it. And then we ended up by talking about union, intersection, and difference. A trip back to 5th grade one more time. Fantastic. Whatever shall we talk about next time? Merriam-Webster's dictionary and what it means for you going forward. And you've got homework number 4 to work on. Life is so great right now. I will see you on Thursday.